into the content that you prepared. So let's start with Chris.
All right. Hello. I'm Dr. Christopher Robinson. And beginning at Center, I was a math and physics major, and I minored in computer science. And I had an electronics course in the physics department, which really kind of changed my whole idea of what I wanted to do. And I decided that I wanted to pursue robotics from that. So I took a couple of courses. Point of fact, Dr. Shannon's course in robotics was particularly transformative. It was a good time. And so after I graduated Center, I got a master's degree in electrical engineering, focusing on machine learning from the University of Louisville. And then I went to work for a startup for a couple of years. Where we kind of did a whole wide range of things. It was sort of a very speculative type of environment there. And when the business kind of settled down and got less speculative, I started looking for something that would be more research oriented, from which I ended up incidentally applying for a research engineering position at U of L again, and ended up sort of redirected into the PhD program. So for a couple of years there, I worked with the Conn Center for Renewable Energy on automation, so automated sample testing and things like that, and then transitioned over to what was at the time the Next Gen Systems Group, which is a robotics research group at the University of Louisville, which is now the Louisville Automation and Robotics Research Institute. Those R's might be reversed. It might be research robotics. I don't remember exactly. So I worked there for a couple of years. I finished my PhD with a focus on AI robotics, and then was a postdoc there for about a year, after which point I transitioned over to a company in Louisville, Kentucky called Phase Ortho, which basically manufactures clear plastic dental liners, which is to say Invisaligns, because they have some really fascinating problems associated with processing digital models and then automating things for that. So it seemed like an interesting project. So that's where I'm working now. So that's kind of my history from starting at Center in doing math, physics, and computer science all the way up through teaching robots how to align human teeth, basically. So that'd be me.
Skyler.
Yeah, hi everybody. My name's Skyler Shasky. So I graduated from Center same year as Chris, actually, 2012. I was a financial economics major, math and Spanish minor, played basketball. I was also an SAE. Loved my experience at Center. Although I will say, like, coming out of college, I still didn't necessarily know what I wanted to be. When I grew up, I had took amazing classes, learned a lot, but I didn't necessarily know my career path. So I landed with essentially a sales job in the financial services industry, where some other Center alums worked for a company in Louisville, and learned a lot there. Had a relatively good experience, but could tell it wasn't necessarily my long-term thing. So I was lucky enough that my aunt gave me some really good advice about kind of like a path to take things, and essentially she told me that data and data analysis and machine learning were incredibly important, and they're learning about them would be good for my career long term. So I went to Georgia Tech and I got a master's in analytics. It was just a one-year program. And I should say, like, part of the reason I knew I was interested in that is I took econometrics and empirical analysis at Center with Dr. Bruce Johnson, where we used SAS and we did some lightweight modeling. I wasn't a computer science, minor like Chris was, but I could tell that was kind of interesting. So went to Georgia Tech, got the master's, learned a lot about, it was sort of like three-tiered program where part of it was computer science, part of it was math, part of it was the business side of data. So things like data visualization and project management. So did that, got a few jobs, kind of bounced around a little bit. I had a job with a consulting firm that built proprietary models for revenue management. I had a job at a startup that did data warehousing and what's called ETL, which is essentially how you move data from one source to another. And then I got a job with Google. which is where I work today. So at Google, I've done a few different things, but my current role is probably most relevant to this conversation. I'm what's called a customer engineer. So I'm still in sales, but I'm like the technical person in a sales effort. So as customers are evaluating Google's tools and services, I'm there to answer questions, help build demos, that kind of thing. And I do focus on artificial intelligence, machine learning tools now. So this year in particular, that's been crazy because of the um, expansion of large language models and everything that's come with that. Every company I work with is asking about generative AI, large language models, how they can apply it to their existing problems and integrate it into their tools. So it's been really exciting. It's been really interesting. A little bit overwhelming too, but I guess that's part of the fun. So yeah, thanks for having us today. Really excited to talk to you.
And last but not least, Henry.
Hi, my name's Henry Lynch, graduated from Center in 2017, played soccer, was an econ and finance major. And after I graduated, I moved to Louisville to work for a high growth technology company called Waystar. I was in the healthcare technology industry and was a system admin and analyst there, and then left after a few years to help co-found a software company called vSimple, where I still work today as the CTO. We use AI to power several of the features within our platform that we extend to our customers, but also use the technology to help monitor our application and accelerate development and speed up kind of the turnaround time for features and that sort of thing that my team's responsible for.
Thank you, Henry. All right, so panelists, do you guys want to hold questions for the end? Do you want students to ask questions as they have them? What's your preference?
I mean,
I think just start firing away questions.
yeah, that's what I was going to say.
Okay. So, first question that I have for you guys is, what does AI look like right now? What's going on in AI?
Well, do you want to hear the sort of R&D academic element first, or more the commercial element first, I guess? Because there's kind of two, because we did talk about this quite a bit actually when we were preparing for the meeting, and there's really two solid tracks right now, and they do kind of look different. I mean, if you like, I can go ahead and start off talking about the academic orientation of artificial intelligence right now, if that sounds good.
Go for it.
Okay, so the thing to keep in mind, I think, right now about artificial intelligence is that people are really super duper excited about generative AI right now. It's the new thing, one of the things that we kind of talked about as a group that I thought was interesting, and one of the things that came up at the last meeting, is that in terms of what people are looking for right now, because it's just kind of GPT and Stable Diffusion happening to come out basically at the same time within a couple of months, seeing wide adoption, has sort of created a sudden demand for people. And you will see sort of like lots of places are looking for what they're calling now, that I'm starting to see in my like LinkedIn recommendations, basically, are like prompt engineering, right? Which is that people are quite focused in a large area on who is able to take the tools that already exist and use them to produce functionally a successful product. The thing that's kind of tricky about that right now is that in the deployment side, it's basically the Wild West. A lot of it is very much informal. A lot of the people who are training to do these things are basically, they're downloading models, setting them up. They buy a $500 GPU video card and are practicing it with themselves, basically. There's no sort of formal structure for which right now you can't officially like train to be a prompt engineer. At least nothing that's like exists in an established thing, nothing that exists in a university yet. In the near future, I'm sure there will be entire courses on it, but at current time, academics has not really caught up with that deployment because it's primarily a product. However, the actual development of the large language models is now in particular Stable Diffusion a bit less so, because Stable Diffusion is essentially a differential equation that you solve. Once it was solved, it's kind of now it's just developing iterative improvements on that. And that's a lot of the focus of labs that are currently working on it. But the large language models have sort of passed an operational threshold now where they produce enough results that there is funding available to develop on them further. But the traditional areas that have been associated with artificial intelligence, specifically in language processing, what has generally been known as natural language processing, NLP, is sort of a little bit more out of bounds now. Previous versions of NLP were highly, they were very much based on logistical models of speech and very much rules oriented, very much classical artificial intelligence. Modern systems are far more neural based, essentially. And so the end result has been that there are kind of two broad categories associated with what's going into the current training for generative AI, specifically with regards to language models, which is that there is the language side and then there's the math side. And the reason that I bring this up specifically is that in terms of preparation for what is being sort of like what academics are starting to realize the demand is they want people with a broad background. It used to be that if you were going to study artificial intelligence, you just needed heaps and heaps and heaps of math. Now, the amount of skills required are sort of branching out from that. And so a diversity of education is really the best way to prepare because, again, academics hasn't coalesced on a singular curriculum, a singular pedagogical approach to teaching how to interact with and teach these systems because they are brand new. Some people have been working on large language models for a very long time, but the sea change over the past year and a half has been so great that the entire field has essentially been turned on its head. So people with a broad range of skills are far more in demand now than they would be otherwise, because a lot of what was done prior to 2015, 2016 is now functionally obsolete. So I would recommend that from the academic side, in terms of what sort of preparation is both coming to be expected and also highly in demand, is people who have exposed themselves to a wide range of different sorts of methods, so that they are familiar enough with the development that's going on in all the different ways that that development is branching out into multiple avenues to take advantage of the new possibilities that are available. So from an academic side, you're seeing a sort of much wider diversity of people being drawn in. I actually very recently saw a university posting looking for doctoral students for an AI lab, specifically who have degrees in psychology, for instance, to give you an idea of just how broad of a net people are casting at this point. So you're already at center, you're already getting a liberal arts education. That's a really good start. Looking at how some of those, thinking about how some of those elective courses can fill things that might be relevant in ways that are otherwise unexpected might be a really good way to sort of get yourself like lined up for the new versions of thinking that are opened up by the new models.
Just to tag onto that a little bit, I think that was really well said. I would add, from my perspective, I feel like companies very much within the past couple of years have just accepted that machine learning and artificial intelligence are going to be a core part of their business, and that their data is an asset. And accepting that, and kind of this growth of AI has led to, kind of to Chris's point, like a bit of an ecosystem around AI where, no offense, you don't have to be a PhD, to be able to work in AI. I'm not that smart. But there's all kinds of roles, right? So you think about running AI at scale, there's data problems to be solved. There's, evaluation of models. There's experimentation with models. And a lot of these tools that are out there, you can be a software engineer level coder and do amazing things in the AI space, but there's completely user interface, point and click driven tools where you can build pretty interesting models as well. And with generative AI, even if you don't know how to code, sometimes you can write code just by, typing in words into some of the models. So the broad skill set point, I think, is a good one. And, I'm probably a little biased, but like when you think about AI ML, that's one problem that can be solved with data, but there's a lot of other problems that can be solved with data, and data is always a foundation to solving these problems. So I would encourage you to think about like data broadly on top of AI ML as a specialty within that kind of arena.
Yeah, I guess the only thing I would add is, yeah, I love that the three of us are all on the call because we have the probably most technical resource possible in a PhD. Skyler, who probably knows a ton more than I do, working at Google, and then I'm the consumer of a lot of AI products that we just pass along to our customers. So when Skyler mentioned that you don't have to be a PhD, I mean, you don't even necessarily have to know anything other than if you make this request and get this data back and present it in a certain way, you can really drive productivity and build some really powerful features for different use cases. So for example, like our platform, no one on my team has deep AI experience, but we have several features where we send like a full project history to OpenAI and say, summarize this, and it summarizes it so that we can keep delivering value to our customers in our no-code platform. So I think it's really cool to see the applications that get built even a layer past where anyone knows how the AI under the hood is working. And I'd encourage y'all to check out just kind of what is possible and play around with the available applications, even if you don't have the super technical understanding of what's happening once you hit enter.
Guys, any questions you want to ask at this point?
What AI applications do they work with? What AI applications do you guys work with, like most?
Well, so on my end, being primarily focused on the constructed end in terms of like, basically you could think about that in two ways depending on exactly what you mean by application, right? So like in terms of systems that are designed to work with artificial intelligences, what I'm personally using like 95% of the time at work is essentially things like NumPy, numerical processing, Keras, things like that, TensorFlow, stuff that basically runs the back-end components of it and allows you to do training and numerical processing, right? So from a research standpoint, you're really looking at utilizing the tools that exist. In particular, because if you're going to go and do something like take a corpus of data, which is sort of like your packet of pre-trained chunk of a model that OpenAI and other people built on top of like hundreds of billions of books worth of data and then modify it to a specific purpose. A lot of times there are different interfaces and end user products that you can use to sort of, like I was mentioning, basically point and click to add data in and train on new things like that. But from a more robust standpoint, especially if you're working either in full on standalone product development or novel application cases, those back-end tools, again, things like TensorFlow and Keras, are generally speaking what you're going to be using, those numerical processing packages, and then you're going to be working off of established packages that you download from OpenAI's GitHub, basically, in order to feed stuff into a data flow and train it. On the other end of it, I sort of don't generally
real
speak.
quick, Chris,
Yeah,
just to clarify, I think it may be helpful to say all those packages he's talking about are within Python for the most part. Like in my experience, Python is the most common language
Yeah.
I'm seeing for practical stuff. But maybe you have a different experience, but I just wanted to add that in really quick.
No, yeah, and it's actually it's become so ubiquitous. I was lucky very much that I started off as a Python programmer, and that's sort of my native programming language, because Python was previously sort of in contention with C as your sort of like primary industrial and commercial language. At this point, I've seen most places are using almost exclusively Python, especially with regards to ML, but for other things too now because you can interface to the AI tool so easily. And I'm seeing some places that are putting it now that C is like a nice to have kind of thing if we need to get down into one of our microcontrollers, but no longer even a requirement for a lot of places. Python is essentially is now the dominant programming language in all of the AI sphere. Almost nothing is in anything else. If you want to, now Henry was talking about user end UI applications, which I'm going to get to in a second because they're super important. But Java and JavaScript in particular, but Java also as a standalone, super important for that because Python doesn't have a lot of great native UI tools for it. And it's not yet fully integrated into web-based activities. You know, you can put Python into your browser, but it's not super adopted at this point in time. So it's pretty tough to like get basic resources. You kind of have to build it on your own if you want to. And it takes a lot of time. So if you're interested in applying that, building a product that you can deploy on a phone or in a browser, then Java and JavaScript are really important for getting that stuff out there, especially for end user applications, which is the other end of AI that I use. It's like just things that you can do in the browser, like Civet AI and Mage.io are the two that I use for image generation entirely for personal reasons. I use them for Dungeons and Dragons, of all things. So, like, you can kind of see that there's basically that entire spectrum in the middle that I, generally speaking, don't touch very much. It's either at the development side, which is, yeah, TensorFlow, Keras, Python, NumPy, things like that, which in retrospect, looking back, one of the most important things that I ever did was a pattern recognition course when I was a master's student in Python, because it taught me a lot of the high speed, heavy duty numerical processing like tools that Python has available to it that are strictly essential now. Like speed is so important. And so focusing on a course that's not specifically AI, but is designed for, you have things like images, big, heavy data sets coming in, and you need to crank through the math to process them as efficiently as possible. Super beneficial in the modern ecosystem. It was a niche area before, and now getting Python with NumPy and those back-end math packages to run as fast or faster than C+ is hugely important because all the tools are built in Python and they need to basically move in real time. So those would be the sort of vicinities that I personally tend to work with more than anything else. Is those numeric processing packages.
On the Python side, like one thing I'll say is, you know, I'm not writing code every day in my job by any means, but knowing just a little bit about how to write code and like being able to whip up a notebook if I need to, and understanding like documentation about code is really, really important. A lot of the tools that are coming out, I mentioned that there's user interfaces where you can point and click, and that's often true, but that often comes after companies will release like APIs where you can interact with things inside of code, but not inside of an interface. So if you want to be kind of on the cutting edge, knowing a little bit of code, I think particularly Python is super relevant. I use SQL a lot in my job too, which is for it's a language for databases and data movement. So, you know, even if you aren't a software engineer, that's totally fine. But taking a class, like regardless of what you end up doing, even if you don't use it day to day, I think like knowing some of those fundamentals is really relevant. And then I'll answer the applications question. It's a great question. I'll answer it in a slightly different way. I'll give like perspective of some of the companies I'm working with, like how they're thinking about using AI. So I'll just give a couple examples. So I'm working with a vehicle manufacturer. One thing they're thinking about is making like the in-seat experience better, in the vehicle. And so they want to, or they are building an application that will, like, how your check engine light or something will come on in your dashboard, and you're like, what on earth is that light? Like, I don't know what it means. It's 3 squiggly lines, and who understands what that is. They're looking to sort of automatically integrate the the like driver handbook or manual, that's the term I'm looking for, with the console in the car. So you can basically have a chat bot, and you can say like, what is this light? Do I need to take care of it right now? What do I need to do in order to give that much cleaner experience in the car? Another one that's kind of fun is working with a dating app that involves swiping. Maybe you crazy kids in college have heard of it. But they're looking to basically like take the profiles of individuals that get matched up, and using generative AI, like come up with suggestions of dates or things that you could do together. That's kind of a fun one. And then this one's not large language model driven or generative AI driven. It's more like traditional machine learning, which is still relevant. So I'm working with a large grocery chain that's looking to improve their forecasting. So, a big problem for them is when they run out of items in their stores, or they're overstocked and they're not able to receive, additional shipments. That can be millions of dollars of lost revenue over time. And so they're looking to do like a huge amount of forecasts at scale on every store, every SKU, and they're looking to do that on a rolling basis to improve their, understanding of kind of the velocity of their items. And so I think, all that to say, from an application perspective, like no matter what you're interested in, AI or ML is probably going to be relevant to it in some way or another. And so that's why I get, really excited about the space in general. And I think, if you guys are at school thinking about what to do, I'm sure there's a million amazing career paths you're considering, but I wouldn't be shocked if you're at the very least interacting with AI tools like Henry is in his day to day. So yeah, I'll leave it there.
Awesome. I have a couple. I can just show you how vSimple uses some of our AI products today. Can you all see my screen?
I got it.
All right. So our platform, customers use it for a lot of different use cases, but one of the main ones is project management. So getting a customer signed and onboarded, invoiced, all those steps. And one of our features is a OpenAI powered summary of kind of the full feed of what's happened with a project, which this one's pretty small, but sometimes there could be, pages and pages of conversation and documents and whatever else that it's helpful to just get a couple 100-word recap on. Very similar to where if you just dumped a ton of text or a URL into ChatGPT and said, summarize this, we format it and present it using JavaScript on the front end. To Chris's point, we're a Vue app, which is a JavaScript framework. And then we also use another Microsoft product that's embedded within vSimple called Power BI that has some AI-based visuals, and one of which is a key influencer visual. So customers are able to tell the dashboard variables that they care about. So active days, that's pretty much the same as processing time. So they're trying to figure out what drives up my processing time for my orders, for my projects, whatever. And then this Microsoft product in the background will go through and say, here are the variables that have the biggest impact. Henry's really slow. he's 61 days slower than everyone else when projects get assigned to him. If your customer does a demo of the equipment, it goes way faster than if they don't. So there's some really cool insights that people can learn about the data that they're managing in vSimple within these kind of dashboard visuals. And then we also use it to parse emails and files. So you can think of if a lot of our customers are heavy equipment dealerships. So somebody places a huge order with them, they then have to go and order equipment from a bunch of different manufacturers, and they'll add a vSimple email address to those orders that they're placing. And then as those manufacturers email them back or send them invoices back or whatever, vSimple can analyze those documents, pull the data that's relevant off of them, and then update their projects and notify the relevant people and that sort of thing. And then finally, we use a technology called Dynatrace, which monitors every request that's going through vSimple. And they have a lot of AI models that will notify my team if a particular service or particular request is going slower than normal for whatever reason. And my team will use that to investigate, and if we need to send out an alert to our customers and that sort of thing.
I want to throw in two very brief notes here to speak to what Skyler and Henry were both saying there too. So to keep in mind, I think that there is still a lot of room and need for classical artificial intelligence. The primary area of my academic research is in planning algorithms, and that is still entirely and wholly the domain of classical algorithms. There are not even neural networks, even sort of generative AI is the big thing right now, but you may remember, or maybe not, kind of depends on where you're at. A few years ago, it was deep neural networks were the thing where all the money was at. And even there, they're not anywhere near remotely as good as classical machine learning and classical artificial intelligence at scheduling planning. So like UPS, for instance, is a massive company that is entirely an AI-backed company. The fact their entire delivery and routing system, they are sort of the archetypal big money company that runs its backbone is artificial intelligence. They have the planes and things, but how it gets to you on time is AI. And it has been since like 2002, but they're all classical AI because they plan much better, much faster, more efficiently. And there is room for there. And it's kind of unfortunate to have to think about it, but there is funding to do work in that space because it is so important. So I think that's worth keeping in mind that the biggest AI-backed company right now, perhaps maybe not necessarily, maybe excluding Google, depending on how you want to look at it, but UPS is a great example of that their entire business model runs on that, and it's classical AI. You just can't beat it for that. Thing number two that Skyler mentioned, SQL. If you can take a course in SQL, take a course in SQL. It's one of my biggest regrets. I had opportunities more than once, and I never did. And it has been such a pain to try and get back into it without an academic course that laid it out properly from the get-go. If you can take a class in SQL, take it. No matter where you go, if you do anything remotely tangential to computer science, AI, any of those things, it will help you enormously. Take a class in SQL if you get a chance to.
And if you try to look it up, it's SQL. People call it SQL,
Yeah.
but it's SQL. So that could maybe be confusing just depending on how you're searching.
Yeah, it's ridiculously important, and it was a big misstep for me to not have one. So I highly recommend that.
Any other questions?
Yeah. So, just to clarify a little bit, you mentioned that with UPS, it was a lot of scheduling. What do you consider that? Like, is that sort of under a broader class of NP-hard problems that classical AI is trying to solve? Or is there I guess, what other problems could you foresee being done in classical AI?
So yeah, the key the key name for the primary problem that UPS needs to solve is called the vehicle routing problem. It's an extension of the traveling salesman problem, which is where you have some kind of agent that needs to go to a specific path of locations to do something, and it needs to make those routes in the minimum time, minimum energy expenditure, whatever metric you want to minimize there. And then the vehicle routing problem is that, but you have a whole set of destinations you need to visit and multiple different agents going to visit them. The vehicle routing problem is known to be NP complete, right? Which is even like a higher tier of that, you know? And so that's the reason that AI is strictly necessary. AI and also combinatorial heuristics kind of as a sort of, there's an overlap there between combinatorics and artificial intelligence, especially classical planning AI, where basically the AI's job is essentially to figure out better dynamic heuristics to apply to get a more efficient solution. So if you then go and look at the entire suite of NP problems, because polynomial time problems typically aren't the domain of artificial intelligence or even heuristic algorithms typically. Usually they permit essentially a discrete fixed solution. In particular cases where you can achieve a polynomial or better solution with a dynamic algorithm, which is another thing that I would highly recommend studying in depth. Dynamic algorithms, they're sort of a lateral thinking approach to algorithmics, and you really, the best way to understand it is to learn a bunch of them and how they work and think about them in sort of a very nuanced and intuitive way is much better, you know, than just looking at the math, right? But usually polynomial problems are kind of generally easy to solve. If a problem is known to be solvable in polynomial time, once you have that proof in hand, you can usually derive a solution just by applying standard techniques pretty quickly. NP hard problems are a different matter entirely. And NP complete problems are basically under intense scrutiny because it turns out that a large portion of the time they're the most important problems to solve, like the vehicle routing problem. But one area that I think is particularly vulnerable to effective and very productive solutions is the set of problems which are not known to be polynomial time nor known to be NP hard problems. Oftentimes there's a whole class, for instance, that are of problems that are known to be isomorphic to the graph isomorphism problem class, which is not known to fall into one or the other, at least last I did any research on it, which is an area of intense like active research because these problems are often very useful. Graph isomorphism is incredibly handy for pattern matching, for recognition, for a lot of planning algorithms, things like that, for numerous like just sort of logistical reasons more than anything else. And that specific class of problems that are of undetermined complexity class are really important problems typically, and you don't necessarily have to be bound by a known lower limit because when you have an AI system that is basically been trained to generate an effective heuristic, as it gets better and better, it asymptotically approaches that lower bound of performance, at which point you get diminishing returns on more work done. But that class of problems, which is of uncertain complexity class, oftentimes you can keep pushing the best known basically the best known complexity class for it, not necessarily with provable effectiveness. You can't necessarily say, oh, it's going to do no worse than this ever, but you can show typical performance that's incredibly useful. And if your typical performance, not your worst case, obviously, but if your typical performance gets down into near polynomial time execution, then you've got something really useful there because you are showing that you have a heuristic that can, for most of the times, which is really what places like UPS and Google and places like that need to know, like 99% of the time, we can get it to within n squared, you know, that's incredibly useful. I think one of the things that academics kind of get hung up on is like worst case performance and provable limits, but like industry thrives on those marginal gains, you know? And so if you can do something that has a clever back end that works out that, again, the vast majority of the time you can give it in essentially polynomial time, you might as well have a polynomial time algorithm to solve a very hard problem. And that's super useful. You can make real change in the world using those best guess, best heuristics that are out there. So in terms of problem complexity, things that are in that sort of gray area, the graph isomorphism, hypothetical class, things like that are a great place to start looking for the kinds of problems you can study. And again, because a lot of those are cracked by combinations of things like dynamic algorithms, heuristics, combinatorics, and AI, goes right back to the diversity that I mentioned before. But there's a lot of room for studying them in a way that, again, sort of requires a good sort of mathematical and algorithmic intuition. And the best way to develop that sense of problem solving is by working with those problems, especially ones that are already solved, and then making adjustments on top of that. Understanding the nuts and bolts of the idea behind the algorithm teaches you how to think in that sort of out of the box way that allows you to really crack into that middle spectrum. So if you were going to study problems in a specific class to see what are most useful out in the world, what you can get the best return on investment for, that those problems of unknown uncertainty class are often the best place to go looking for things to work on and things to practice with and understand. I personally have a very strong adoration of the graph isomorphism problem, so that's why I use it as an example. But there are lots of different sorting problems out there that exist. The job shop scheduling programs that are out there, very important for things like scheduling your processors in your computer, assigning cores to tasks and things, stuff like that, where there is a lot of dynamic heuristic work, and you can often characterize those problems in the wild by finding out when there are 100,000 different proposed solutions and methods for different cases, where people look at a specific set of restrictions on the problem that apply to a narrow subclass, and then they find a really good solution there, and then other people working on another narrow subclass to use the specific case to sort of get a lever against the problem and make it run more efficiently. So looking for those edge cases is where I would say there's a lot of value in the study element of it and the understanding where there's leverage to be gained. The parts that are not in one or the other, but kind of vaguely, maybe they can be solved in polynomial time, that kind of a thing. So that's where I would go looking, I would say.
Thank you so much.
Mm-hmm.
We've got time for one last question, if anybody has one. So let's say that students, they're looking for an entry-level position in the field of AI. What sorts of keywords should they be searching in order to find those positions?
Well, I think part of the way I would answer that is going back to some points we made earlier, which is your work can be tangential to AI without being like an AI researcher or developer. So starting with, part of what I've done in the past is focused on jobs that use tools that I like to use. So like I know how to write in Python and SQL. So a lot of times those are listed in the requirements for job descriptions. And if there's a BI tool like Power BI, Henry talked about, or certain coding language or something like that you'd want to work with, you can search for those. But then a lot of it, like in my experience, a lot of stuff that is related to AI is in the data realm too, right? And so there's things like data analysts or data scientists type roles, which may involve ML AI, but not like as the every hour of every day component of what you're doing. So expanding your search to be like data related on top of AI related would be a big recommendation as well.
All right, gentlemen, I thank each of you for participating today. Let's give them a big round of applause.
Thanks, everybody.
Yeah, appreciate it.
Thank you much. It was a good time.